Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay, should be same. Okay, until then this process will be repeated. Okay, nth cluster should be same as n-1 cluster. Until that this process should be repeated. Okay, so once it is same, it will stop doing the process. So this is called k-means clustering. So guys, clear?
So one point.
So clear with this?
One clarification. So it will, for each point,
yes.
Each point it will be finding nearest centroid, right?
Yes, exactly.
So the next thing you said, like then how the changing the centroid, you said, right? I did not get that.
Yes, the thing is we have some formula for that. Okay, that is by using the existing centroid and average of all the centroids and average of all the data points. So we have some formula for that actually. Okay, that is in order to change the centroid. So that we will see during implementation. Okay,
so process wise it will be identifying another 3 centroids and again the same calculation.
Yes.
Okay.
Exactly. So it will be changing the centroid basically. Because initially it is just choosing some random centroids, right?
Okay.
It is choosing some random centroids now. Okay, so like that. So the centroids updation will happen. Okay, the centroids updation will happen until the cluster of n iteration and n-1 iteration will never change. Okay, if both are same, that's it, it's done like that. Okay, so now what we will do, let me just take some random data points actually. So let's say data frame. Okay, and then I will take some 2 data points like x, okay, and then y. So these are not independent feature, dependent feature. So there is no label here. There is no evaluation matrix here with respect to unsupervised. Why we don't have evaluation criteria here? Why we don't have evaluation criteria? Because we don't know the actual values. Okay, we don't have the actual values at all. So whatever you cluster, that is a cluster. That's it.
Yeah.
Okay, whatever you group, that is the group. We have to take it. Okay. So now let's say something, I'm giving something over here. Simply I'm giving some points.
So then again, what we will be saying that it is the algorithm is proper.
Sorry.
So then how we will be able to use this algorithm, since the outcome it is not predictable, right?
That's why we are undergoing several iterations, right? So we are not stopping with a single iteration, no.
So normally in which scenario we will be using, is it just kind of a suggestion kind of algorithms? If we need, then we will be going.
Yes, recommendations, suggestions. Yes. The thing is, like if you see Netflix, Amazon Prime, so the movies will be categorized, right? Like thriller movies, horror movies, action movies, like that. So that is nothing but unsupervised clustering. Okay, right. So now we have something like, let's say, len of data of x, which is 19, and len of data of y, and we have 19, and then let's say data dot head, we have something like this. Okay, so now what we are going to do is, first we are going to dynamically give the centroids. Okay, for the time being, let's say k is equal to 3. Like we are going to say some 3 centroids actually. Okay, all right. So now let's say k is equal to 3. Okay, and then I can write np.random.seed of 200. So yesterday, remember we did something like what was that? Random state. Remember we were talking about something called random state in train test split.
Yes, so that it will
Okay,
be
yeah,
each the data
yeah,
that
exactly. There is the same set of records will be taken. So similarly, if I set, so that random state is equal to 42 is nothing but seed only. Okay, so here we are assigning some seed, something randomly, because in order to generate the same centroids whenever you execute this particular script. So the first centroid will be same as always. Okay, see here, let me just apply the centroids now. Centroids is equal to, okay, let me write a dictionary comprehension, that is I, okay, let me just write it for I in range of 1 comma k plus 1. Okay, that is range of 1 comma 4 basically. All right, range of 1 comma 4 means it will take 1 2 3. All right, and then I can say I colon, okay, I colon, so okay, let me just to give 3 means 0. Okay, let me just take it like that itself. That is range of k. Range of k means now it will take 0 1 2 basically. Okay, and then I'm just writing np, okay, np dot random dot rand int between 0 comma 80. This is the first point, that is x-axis, and this is y-axis, 0 comma 80. Okay, now if I print the centroids, you will be having 3 different centroids. That is for cluster 0, it is 26 comma 16. For cluster 1, 68 comma 42. And then for cluster 2, it is 55 comma 76. Okay, for example, if I comment this line np.random.seed of 200, if I comment that line, whenever I execute, you can see different centroids. See, you can see different centroids. But now if I set this particular random seed, now you will get only the same centroids whenever you execute it. Got it? And you guys are getting it right? That is, this is nothing but dictionary comprehension. That is, we are looping through for I in range of k. So what is range of k basically? Range of 3. So range of 3 means it will take 0, 1, 2. So that's why it has taken 0, 1, 2. That is for cluster 0, 26 comma 16 is the point. For cluster 1, 68 comma 42 is a centroid, and for cluster 2, 55 comma 76 is a centroid. So now let's plot the centroid now. Now plot the centroid. So I can say figure is equal to plt dot figure. Okay, so fixed size is equal to something like 8 comma 5. Okay, then what we are going to do is I'm just saying plt dot scatter. Okay, I can say data of x comma data of y, and then I can say color is equal to black. So this is nothing but data points, the one which we have it over here. First one is 12 comma 39, then 29 20 comma 36, 28 comma 30, like that. Now we are going to plot the centroid. Okay, now we are going to plot the centroid. That is, I can write for I in centroids. Okay, for num or else for n in centroid. So now whenever I say n in centroids, what will happen? It goes through the keys. Now if I say print n, what will happen? It will print 0, 1, 2. Okay, that is, it goes through keys basically. 0, 1, and then 2. 0, 1, 2. Now what I am going to do, I am just plotting this one. That is plt.scatter plt dot scatter. I can say centroids, okay, of I and then 0, comma, centroids of I and then 1. That is, centroids of I is what? Complete this thing. Now this is x-axis and this is y-axis. This is x-axis and this is y-axis. Okay, and then you can see it now. Okay, let me just name I is not defined. Okay, I have to give n here. Now you can see 3 clusters. That is 1, 2, 3. Okay, let me just increase the size of it. S is equal to 100. Now you can see the centroid. That is over here, over here, over here. So if I want to give our own color, I can just write color map. That is, C map is equal to, if it is 0, that means red. If it is 1, that means green. If it is 2, that means blue. Now what we can do over here is, I can just write color is equal to C map of n. Now you can see, or G B. Got it? C map of n. So what is n basically? 0, 1 and then 2. So it will take the color from here. Like if I say C map of 0, it will be taking red. If I say C map of 1, it will be taking green. And if I say C map of 2, it will be taking blue. So guys, clear so far? Guys, any questions so far?
Not from my end.
Okay. So here
Mohan, I just lost you for 5 minutes. I think I lost from that plot.scatter.
This one.
Yes, yes.
Everybody else were able to hear me, right?
Yeah, I could hear.
Okay.
Yeah,
So
I had some network issues. Yeah.
All right. See, here what we are doing, here we have this centroid, right? We are going to plot it. Okay. So for n in centroids, that is, we are looping through the dictionary. Whenever you loop through the dictionary, it loops through the keys. That is, n will be 0, n will be 1, n will be 2 in each and every iteration. All right. So now if I want to plot, that is, this is x, this is y. So how can I retrieve x? I can say centroids of 0, 0. For example, if I say over here, okay, if I say there is centroids of 0, I'll be getting 26,16. Correct? But I need to place completely, that is x separately, y separately. So in that case, I have to say 0, 0 and then hyphen centroids of 0 and then 1. So now you can see 26-16. We have splitted it. So that's what we have written it over here. Okay, and then color. We have defined a color map here. For cluster 0, I am assigning red color. For 1, I am assigning green color. For 2, I am assigning blue color. So I am just saying C map of n. So n will either be 0, 1, 2, right? So depends on that, the color will be assigned. Got it now?
Okay. Yeah.
Got it now? Okay. See, now either I can do like this or I can just say like this actually. That is star centroids of 0. Now you can see 2616. That is, whenever I say star centroids of 0, whatever is present, that will be taken for subsequent parameters. Okay. So now instead of doing this, I can just write, let me comment it out. I can just write star centroids of n. Now you can see the same output. Okay, instead of writing separately like 26,16 like that, I can just write star centroids of n. So it will take both the points as X and Y. Okay, it's a feature of Python basically. Star and double star, you would have heard about it. Okay, star args, double star kwargs, like that. It will take all the parameters consecutively. Okay, that's clear so far? Yeah, please take it down and then we will proceed. So please take it down and then data, and then I can just give this one. Okay, let me know once it is done. Then we will start grouping it. Okay, so far we have just highlighted the centroids, so that's why I have made all the data points in black. Okay, so we have to cluster it now.
And from my side.
Yep.
From my end too.
Okay, so what about the other one?
Done.
Yeah, so now we are going to assign the data points to appropriate cluster. Okay, we are going to assign the data points to appropriate cluster. Okay, so I can write def assignment. Okay, and then I can say the data frame and then the centroids as a parameter. Okay, now I am just going through the centroids. Okay, and then I can just write println for the time being. Okay, so now let me just call it like assignment. What is the data frame? It's data. Okay, data comma centroids. So now if I do, you can see it is printing the centroid name, sorry, centroid ID like 0, 1, 2, like that. Now what I'm going to do, so now we have the data frame like this. Now we are going to add some column, like, that is, we need to find the distance, right? That is, let's take this one, 1239. Okay, now what we have to do in this case, that is, this is a centroid. So I have to say, that is 12 minus 26 the whole square. Okay, 12 minus 26 the whole square. Okay, plus, and then 39 minus 16 the whole square. 39 minus 16 the whole square, and then we need to say the square root of. So this is nothing but distance 1. This is nothing but what? Distance from cluster 0, let's say D0. Okay, and then next one is what? 12 minus 68. 12 minus 68 the whole square. Okay, plus, and then I can say 39 minus 42 the whole square. Okay, 39 minus 42 the whole square. So this is nothing but D1. Okay, this is nothing but D1 actually. Similarly, we have to calculate D2. So we have to store these three as a separate columns, like this distance from cluster 0, like D0, and then all distances, and then D1, and then all distances, and then D2, and then all distances, like that we need to store. Okay, and then from this we have to find which is closest. Okay, from these three parameters we need to find which is closest. All right, so for that what we can do is, okay, for that what we can do is, I can just write over here, first we can create the columns, create the distance columns. Okay, that is, I can say distance calls is equal to, I can just write distance from, or else let's say d, and then I can just write n, okay, or else d and then something like this, like I can say format of n. So basically this is nothing but placeholder that we used to say in Python. Okay, this is nothing but placeholder. That is, whatever we are passing the parameter over here, that will be substituted. Okay, let's say distance underscore 0, something like that. Okay, and then format of n, and then I can write for, okay, n in centroids. Okay, so let's say like this. Okay, so now if I just print this, now you can see. Okay, now you can see. Let me just I think this should be outside the loop, right? Sorry, print n. Okay, let me just outside keep it. Okay, okay, now if I print like dist calls, okay, so now you can see something like this, like distance underscore 0, distance underscore 1, and then distance underscore 2, like this. So we have created some 3 columns over here. So guys, clear on this? Yeah, everyone? Guys, clear?
No.
Clear with this so far? What is your doubt?
I missed somewhere that distance. Okay,
Okay,
can
see,
you? I just got it.
see, the thing is, here we have x and y. Okay, so we are just saying, like we are just adding 3 more columns here, like distance from 0, cluster 0, distance. Did you understand the formula that I have written?
Yeah, that part I understood. I distance
yeah.
also. Okay.
Based on the distance, we are going to assign the value. So
Okay.
over here, what we are doing, we are just creating the columns. Actually, that's it. That is where we are just naming the columns. Okay.
Okay.
And then what we can do is over here. Okay, I am just writing like data of. Okay, that is sorry, df of. Okay, df of, and then I am writing distance underscore something dot format of n. Okay, or else what we can do is df of n also should be fine actually. So we can, instead of doing this, I can just write dist calls of n. That is, n is 0. This is 0, right? This is 0, this is 1, this is 2. Correct? So now what will happen? See, now what will happen here is, if I execute this, okay, now if I say return df, now you can see here df is equal to, let me say, and then I can just say df dot head. I'll be having something like this. Okay, so that is distance 0 is 1, distance 1 is 1, distance 2 is 1. All are getting it, right? Okay, since I have it here 1, it is just taking like that. That's it, nothing else. Okay, so now over here I am just writing, okay, np dot square root. Okay, np dot square root. Then we are writing the formula basically. That is x1 minus x2 the whole square plus y1 minus y2 the whole square, like that. That is, I can say df of x minus centroids of n and then 0, okay, the whole square plus, okay, and then again df of y, okay, minus centroids of n and then 1 the whole square. Got it? So everyone, that is x1 minus x2 the whole square y1 minus y2 the whole square. Got it, everyone over here?
Yeah. Yes, yes.
Okay, so let me just write it like this. It is not to simplify. I will write it like this. Okay, so x1 minus x2 the whole square plus y1 minus y2 the whole square, like this. So now if I execute, you can see the distance. Okay, now if I execute, you can see the distance here. So distance 0 is 26.9, distance 1 is 56.0, distance from cluster 2 is 56.7. So now which is closest out of these three? Out of these three, which is closest to this one?
First Centroid is
0, right?
closest.
Yeah.
0, right? Yeah.
Great.
Centroid
Yeah.
0, this one. So now our next step is find the closest distance. Find the closest distance. That is, I am creating one more column called closest is equal to, okay, and then what I'm writing is like df dot locate, okay, and then I am just considering all the records from data frame. Okay, I'm considering all the records from data frame, and then I'm considering only these columns alone. I'm not taking all the columns. I am just considering only these columns alone. So for that we have this one, right? Like dist calls. Okay, so what is dist calls? Distance 0, distance 1, distance 2. Correct? So now what we are going to do is we are finding the minimum value from this. Okay, we are finding the minimum value and we are writing the index out of it. Okay, so I can just write dot idx min and then axis is equal to 1. So whichever is minimum, okay, it finds the minimum and writes that particular column to this particular value. See, now if I do like this, you can see here. So closest is distance 0. And if you see the second one, what is the closest? Distance 0. And if you see the third one, distance 0 is closest. If you see index 3, you can see distance 0 is closest. And if you see index 4, which is closest? 34, and nothing but distance 2. Okay, so we are just retrieving the column name like this. Guys, understood?
Yes.
Yeah. So, and then what we are doing, we are just taking only the cluster value, not distance underscore. So we are just removing this. So hope you guys know trim function. Hope you might have heard about trim, like removing the trailing white spaces and leading white spaces like that. So similarly, we have something called strip. For example, consider I have a string, okay, like distance is equal to 0. Sorry, distance underscore 0 like this. Now I want to remove everything. I want to remove everything. So what can I do is I can just say string dot strip of distance. That's it. So now I will get only 0. Got it, everyone? So if I say string dot strip of distance underscore, whatever distance underscore is present at the leading, okay, and trailing will be removed actually. Okay, now I'll be getting only 0 here. So now what I'm going to do, I'm just writing df of closest is equal to df of closest dot map. What is map basically? What is map? For n inputs, we'll be having n outputs. Correct? N inputs will be having n outputs. That is, all the records will be sent as the parameter. So I can write map of lambda x colon, and then I can just write x dot l strip.
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
Okay, or we can write strip itself, strip of distance underscore. Okay, distance underscore. And if you see it here, we have the in string format. Okay, so now I want this should be in integer format, so I have to say int of. Why I'm converting to integer? Because if you see the centroids, I have taken an integer here. This is integer, this is not string actually, right? This is not string, so I need to typecast it over here. That is, I can say int of something like this. So now you can see the output. I'll be having only the cluster ID, that's it. I don't have like distance underscore, I like that. Okay, I have only the cluster ID. So now if I have the cluster ID, now what we can do, we can easily retrieve the color. That is, I can say df of color is equal to df of closest. Again, I can just write dot map, okay, lambda x, and then I can say cmap of x. What is the cmap of x? It's a dictionary. That is over here. If it is 0, it will be red. If it is 1, it will be green. If it is 2, it will be blue, right? So now you can see if it is x, that is if it is 0, it will be changed to r. If it is 2, it will be changed to blue, like that. So now check it out. Guys, clear? Everyone? The formation of these columns?
Yes.
Guys? Yeah? So now let's plot it. Okay, now we have done this one, right? Now let's plot it. Let's copy this entire thing. Okay, and then I'm just going to place it over here. So here, instead of giving the color, what can I do? I can just give, okay, I can just give df of color. So it will take x, it will take y, and it will take r. Okay, so it will be plotted like this: 12 comma 39 comma color is equal to r, 20 comma 36 comma color is equal to r. So 29 comma 54 comma color is equal to b, like that. So now you can see the output. Okay, now you have something like this: blue, and then we have something called red, and then we have something called green, like this. But if you see, this clustering is not proper. Okay, now we have some other property also, like alpha is equal to 0.5, that is transparency of the particular color. Now if I say this one, now you can see it will highlight the centroids and all the data points will be it will be transparent. Now if I say alpha is equal to 1, right, you can't see those points at all. It is, sorry, if I say 0, right, you can't see those points at all. It is completely transparent now. Okay, so if I say like 0.1, and then you can see very light color. Okay, and if I say 0.5, it's something like 50-50. So guys, clear? So this is the first iteration. Okay, this is like what we have done here is, this is the first iteration. So initially you can see, okay, how the clusters has been assigned. So guys, clear? Any doubts so far? Any doubts so far?
No.
Okay, so yeah, so please take it down and then we will try it out. So you have to write this, and then you have df.head, and then you have that plot it again. Okay, you can remove this actually, not required.
And for my end.
What about others?
Done.
Done. Okay. So now I can say import copy. Okay. Guys, there are two different copies available. Okay. Like shallow copy and then deep copy. Okay. The thing is, consider I have a list is equal to 1, 2, 3. Okay. And then let's say list underscore A. All right. Now if I say LSTA is equal to, sorry, LSTB is equal to LSTA. Now in this case, what will happen? This will perform shallow copy. That is, both the references and the data are copied. Okay. So whenever you modify B, A will also be impacted. Whenever you modify A, B will also be impacted. So if you want to know the IDs, what you can do is you can just say ID of list A, and then there is the references. If you want to know the references, okay, you can use ID function basically on any data type. So now you can see it is pointing to same reference 052808, 052808. Now what will happen if I modify A, let's say LSTA dot append of 4 and LSTB dot append of 5. Now what will happen if you print LST underscore A and then LST underscore B, it will be having the same value. So here I am appending only A, and in the second statement I am appending only B. But you can see the value, both are pointing to the same values always, because it will copy the reference also. This is called a shallow copy. So now there is something called deep copy. Okay, that is something called deep copy now. So in that particular case, I'm just saying LSTA, okay, LSTA of colon. That is, I am copying only the data, not the reference. Okay, so copies only the data, not the reference. Okay, so I can write, this is called as deep copy. Okay, so in this case, what will happen? Both will be having two different IDs, because both will point to two different references. And if you modify B, A will not be impacted. If you modify A, B will not be impacted. So now you can see this is just 72712, and here you can see 61960, and then list A is 1234 and list B is 1235. Okay, this is called shallow copy and this is called deep copy, and this can be achieved using module copy also. So now we are going to perform deep copy. Now we are going to perform deep copy. That is, I'm just saying old centroids is equal to copy dot deep copy of centroids. Okay, copy dot deep copy of centroids, so that we will be having a backup of centroid point. So if we modify this object, this will not be reflected, because both will point to two different IDs. For example, if you say print ID of old centroids and then ID of centroids, it will be different. See here, it will be different. Okay, that is the difference between deep copy and this one. Okay, so now we are going to, so guys, is it clear, everyone? What is the difference between shallow copy and deep copy? Guys, is it clear?
Yes.
Yeah. Okay. So now we are going to update the centroids. Okay, now we are going to update the centroids. Let's say DEF update centroid. Okay, I can write for n in centroids, that is centroid. Okay, Then I can write centroid of n and then first 0 point. That is, we need to update 2 different points, right? Okay, I can write np dot mean, and then I can write df of closest is equal to n. Okay, is equal to n. What is this df of closest is equal to n? For example, if it is 0, I am taking all zeros actually. I am taking all zeros and then x values. Okay, so and then I am taking x over here. So basically what will happen here, so if I just execute this, I can just say 0. So now you can see only this centroids are there actually. Okay, so df of closest is equal to 0. It is taking everything. Now I am taking only x from that. So now it will be like this: 12, 20, 28, 18, 33, 55. Now I am finding the average of all these points. That is 27.66. So now this is the x-axis for newest centroid for centroid 0. Now the old centroid is 26 for x. Now the new centroid will be 27.6666 like that. So guys, clear now? So guys, clear? So similarly, I can just take it like centroid of n 1. Okay, and then I can just write y here. Okay, so for example, if I say something like this, this is x and then this is y. Okay, this is y. So now you can see 36. Okay, and then return this centroid now. Okay, return centroid. Okay, now I can say centroids is equal to update of centroids. I have updated it now. So now let me just print old centroids, and then I am printing the new centroids. Now the centroid is changed. That is 26,16 is the old centroid, and new centroid for this cluster is 27,36. And then again 1 is this and 1 is this, and then 2 is this and then 2 is this actually. Got it? So now what we can do, we will just plot the centroid. That's the centroid actually. Okay, we are just plotting the centroid alone. Okay, so let me just say here I can say 0. Okay, then I can just see the centroid has been changed. So before, the centroid is somewhere over here, right? If you see the blue color, somewhere over here, but now you can see somewhere over here. So guys, clear? Guys, everyone is clear with this? Yes.
Yeah, mine I lost connection in between.
Oh, okay. So from there,
Can you scroll up a little?
so what about you, Abhishek and Ranjit?
Clear more.
Yeah, clear, right?
Yeah,
Abhishek,
only towards the last part. Only towards the last part I missed.
here is it. Yeah, so basically, we have just called the centroids actually. So like we are finding whichever is the closest to that particular centroid. Okay, and then we are just finding the average of all that particular points. Okay,
Okay,
that is, we are taking, yeah.
I was
just
there
taking
till
the
the deep
average.
copy. Yeah. Deep copy part I was there. So then after
Okay.
that.
And then we are just updating the centroids here. Okay, so we are just updating by taking the average of all data points which is assigned to that particular centroid. Okay, so see, for example, if I say df of closest of C, okay, because if I explain it step by step, then you will be clear. See, now if I do this right, what will happen? It will just display only those records like df of closest equal to 0. Okay, and then we are taking only x from it. Okay, so whichever has closest equal to 0, and then we are taking the x from it. Okay, so these are the x values, and then we are finding the average of it. Okay, that's nothing but 27.66. Similarly, we are taking the y values and then we are finding the average, and that is the new centroid for this cluster 0. Okay.
Okay.
Got it, Susan? And we are just putting it in the loop, like 0, 1, 2, like that. Okay, so now you can see these are the old centroids, like 26, 16, 68, 42, 5, 76. These are the old centroids, and then you can see the new centroids over here. Okay, then we are just plotting the new centroids alone by making alpha is equal to 0 for this. Okay, then what we have to do is we need to repeat the assignment stage. Okay, that is we need to repeat the assignment stage. So what is the assignment stage actually? Let's say df is equal to assignment of df comma centroids, right? Then we can say df dot head. So now you can see something like this. Okay, something like this one actually. So what is that one actually? Once again. Oh, it will change completely, no? That is the problem with the Jupyter Notebook. One second. This is the first one. Then we are executing it. Load the centroid. Yes, that should be fine. Then something. Okay. Yeah, then we are updating it. Okay, then hold centroid. Yeah, then we are plotting it. Then we are doing it again. Yes. So this is nothing but repeat assignment stage actually. Okay. So now what we can do, we will just plot it again. Okay, we will just plot it again, and then we will see how it is behaving. Let's say 0.5. So now you can see somewhat is okay, right? That is, except only one data point, everything is clustered properly. You can see it here, right? Except one data point, everything is clustered properly. You can see it over there, right? Okay, so now what we can do, we can just write the iteration, that is continue until all assigned categories, okay, all assigned clusters don't change anymore. That is, I can write while true. While true means it will always be satisfied. Okay, because it is a condition, like it is a true condition. Okay, it will always be satisfied. Then I can just write closest centroids. First, I'm copying the oldest centroids actually, like df dot closest dot copy of deep is equal to true. That is, we are copying alone this particular column. Okay, we are copying alone this particular column based on deep copy. Okay, and then what we are doing is we are updating the centroids is equal to update of centroids. Then we are repeating the assignment stage. Okay, then we are repeating the assignment stage actually, that is assignment of df comma centroids. Then we are checking it check whether the closest column, okay, of nth iteration is equal to closest column of n minus 1th iteration. Okay, what we can do, if closest centroids dot equals of df of closest. Okay, if this is the case, then break it. Okay, that is, see, first we have copied that particular column and we are saving into one particular variable, and then we are doing the assignment stage. So this will populate some closest, right, df of closest, right, and then we are just checking whether the closest of nth iteration is equal to closest column of n minus 1 iteration, whether both are equal or not. If it is equal, just break the loop. Okay, like this. And then now you can see the new centroids. This is the final centroid: 23.42, 44.577, 62.3, 15.8, and then 50.0 and 63.16. All right. So now if I plot it, then all the data points will be matched properly. You can see. Got it?
Can you explain that last while loop once again? How the n and the n minus 1 was?
Okay.
How did we break? Yeah.
See, this is nothing but, see, yeah, first we are taking the previous closest. See, before assignment, we will be having some data frame, right? See, that is what we are doing is, let me just write it over here. So closest centroids is equal to this, correct? So we are taking only the particular column. Okay, that is before the next iteration, we are taking the current df of closest column. Got it? Got it so far? Right? And then we are updating the centroids, and then again we are doing this one, df of assignment of df comma centroids, like that. So once we do that, let me print. Okay, we have to print in this itself, that is better. Oh, what I did? Okay, I just did this. Yeah. Okay, so now let me just print it over here itself. Print closest centroids, that is n minus 1 iteration. Okay, closest centroids dot values. Okay, then now we will be having something like this, right? Okay, so let's say print nth iteration like df of closest. Dot values, sorry, dot value. Okay, and why this is getting printed, let me just comment it out. Where is it? Assignment. Okay, now you can see all values are same. Got it? That is, we are taking the backup of the previous centroid, sorry, previous closest column, and then once we assign it, then again I am taking it. Okay, n closest dot values, and then again we are checking it. So if both are equal, just break. What is the purpose of break? It will come out of the loop. if you don't have this particular statement, it will keep on repeating it, because here we have while true. Okay, so this will be keep on executing it actually. Guys, now it is clear. Guys,
Yeah, is it assured that always there will be that n yeah,
Yeah.
that n and n minus 1 at one point it will come true?
Yes, definitely it will come. That's why because we are taking, if you see the update of Centroids, right? If you see the update of Centroids, right? We are taking the average, right? Average, right? See, for example, let me do one thing. Okay, let me do one thing. So let me do one thing over here. Just a second. I will just write this particular stuff. Okay, so I will not do anything else at all. All right. So let me just execute this one. That is this one. Okay, and then this one. Let it be, and then I'm just creating assignment, and then this, and then this. This is the first iteration, guys. Right? This is the first iteration. Okay. Now what I am going to do, directly going here. That is, I'm just directly going to this one. So now you can see. Okay, that is n minus 1 is this. Okay, nth is this. So now if you compare this, these two are not equal. So that's why it has repeated for another iteration. Got it? Here, this particular cluster is not matching, like 2 0 0 1. These two clusters didn't match. That's why it is going for next iteration. So now if you see again 2 0, this is not matched. Yeah, only that is not matched actually. And if you see the last iteration, everything is set. So definitely at one time, okay, at one point of time, everything will be matched. See, now it has undergone 3 iterations now. Got it, guys? Everyone? Guys, clear with this?
Yeah.
Yeah. Ranjit and Abhishek?
Yeah.
Yes.
Yeah. So now you can see the data points here. It's properly clustered. Okay. Got it? Yeah. So please take it down, and then we will see with machine learning library. So till what you have done, assignment. Okay. From update, you have to take it down. Yeah. So take this one. And then if you want to take down this shallow copy and deep copy, please take it down. Shallow copy, deep copy. Then you have to take this update stage. Then you have to take this one, update the Centroids, and then just call this. Or else do one thing, don't take this one, the last line. I will directly place that this one, okay, that while loop. While loop, then you can plot it. You can print the latest Centroids, then you can plot. Yes. So please take it down and then let me know once it is done.
Please enroll our general membership for $3.99 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.